In this section, we're going to learn how to decompose a rational expression. That method is called partial fraction decomposition. Let's talk about how we're going to set this up. Well, in order to better understand how we set this up, let's go back to what we've done in past math courses. Here you can see we've added two rational expressions together. And in the past, we've also subtracted them. The method has always been find a common denominator. And once you have a common denominator, you can add those numerators together and keep that common denominator. And actually, here we have the simplified rational expression. Partial fraction decomposition is going the other way, starting with this rational expression and coming up with two simpler fractions. So sometimes it's nice to know what we're doing before we do it. So partial fraction decomposition starts here at number 1, and then we end up here at number 2 with our simpler fractions. And this will be a sum. Okay, so using this example, starting with this rational expression, we're going to decompose this and then come up with these two simpler fractions. So here we go. Here is how we do this. We set this rational expression equal to, and we will use capital letters, and in this case, these are what we call non-repeated, let me just write that here, non-repeated linear factors. This is really important because this method I'm showing right here, in other words, this formula, this is actually a formula in order to decompose this rational expression. These two factors are not repeating and they're both linear, okay? Not repeating and they're both linear. And in that case, we use an A over the first factor, and you can work these in any order you want. You could have put a B over that, but we'll just keep them in order. And then plus B over this factor, okay? So now what would we do in order to solve for X here? As you can see, I have a little note here to multiply both sides by the common denominator. So really what I'm saying is for this side of the equation to multiply by x plus 6 multiplied by 3x plus 1, and the same with this. Let me see if I can move this right there, and I'll go ahead and write an arrow there. And then again, this side, x, let's go ahead and write this, x plus 6 multiplied by 3x plus 1, okay? And again, this is what we started with, and this is the formula, okay? So what happens when we do that? These cancel each other out, and we're left with 19x plus 29. And now we're going to distribute this multiplication to both of those terms. So in the first one, the x plus 6 will cancel out, and you'll just have a times 3x plus 1. Now, when we distribute to b, and let me see if I can erase that little x plus 6. Now, the 3x plus 1 will cancel with this next distribution, and we'll have a b times x plus 6. Okay, so that's where we're at, and this is what we're going to do. We have to solve for A and B. Now, there are several methods. If you would look in the textbook, you would see a different method. So I like to teach this my way. But you could look in the textbook. I'll just put textbook there. And once we come up with A and B, we will have these two factors. Now, we already know that we should come up with A equal to 5 and B equal to 4. And let's see how we can do this. Well, what I like to do is I like to remove a factor. Since this is a polynomial, you are allowed to let x be any value you want. So I'm going to first let x equal -6. And if I do that, I've got 19 times -6 plus 29 equals A times 3 times -6 plus 1 plus 0. Because here, if x is -6, we will come up with 0. Okay, so now we'll go ahead and multiply 19 by -6, and we get a negative, whoops, I want to be in purple, a negative 114 plus 29. And of course, we have 6 times 3 is 18, but that's a negative 18 plus 1 is a negative 17a. And then we have 0 there. So if we have 29 minus 114, we have a negative 85 equals negative 17a. And dividing both sides by negative 17, we come up with A equal to 5. Now, take a look up here. A is the constant in the numerator with x plus 6 in the denominator. Okay, so now what value would make that factor 0? You guessed it, x equals a negative 1/3. So now we have 19 times a negative 1/3 plus 29 equals 0 plus b times a negative 1/3 plus 6. Now you'll have to get your calculator out to combine some of these values. If you want to pause the video, you can. So we have 6 minus 1/3, and you can use math frac on your calculator. So that's pressing math and the math button and then number 1, and you will be able to reduce these improper fractions. So I have 17/3 times b. So let's go ahead and add the 19/3 to the 29. And I have 68/3 equals 17/3 times b. And of course, you can see that b is going to be 68 divided by 17, which is 4. Here I divided both sides by 17/3. So what did you notice? There's the 4. So here's what I want to show you. Once you find A and B, you want to use this formula right here to rewrite your rational expression. So what we want to say right now is we want to say that 19x plus 29, and let's go ahead and divide these by, what did we start with? X plus 6 multiplied by 3x plus 1. And we had said that that's equal to a over x plus 6. But now we'll say that's equal to 5 over x plus 6 plus 4 over 3x plus 1. And that's how we're going to decompose rational expressions just like this. Okay, so just want to make sure we had that correct. You can see the method. My method is to allow x, or to let x equal a value that wipes out an entire term. So that actually wiped this whole thing out when I let x equal to -6 and so forth. And it allows me to solve for the other variable. Let's give it a try. I do want to show you the different, how do we begin? I do want to show you the different forms, okay? We just had non-repeating linear factors, okay? So basically you do want to factor your denominator if it's not factored already. Ours was factored. We also want to make sure that the degree of the numerator is less, not less than or equal to, but less than the degree of the denominator. If it's not, you might need to divide, if this is the case. Okay? And then the denominator will factor into linear factors. You might also have quadratic factors, and some of those might have irreducible factors. So there might be one or more of these types of factors. Okay, so just take a look at them. Powers of irreducible quadratic factors, irreducible quadratic factors, and so forth. Here's what we have, and I will show you the forms that we will use, and it's very specific. Distinct means non-repeated. That means they are unique linear factors. And how you would set this up is just like I just showed you. A over x minus 1, b over x minus 5, plus c over 2x plus 5. And then we would use that same method to solve. Now, if you do have a repeated linear factor, can you see here? It's repeated. That's x plus 1 multiplied by x plus 1. Here is the form you have to use. We will have that a over x minus 8. And we will have the b over x plus 1. But now we have to introduce a c over x plus 1 squared. So that's how we deal with the repeated factors. And if this was a cube, you would do the same thing here and then add a d divided by x plus 1 cubed, okay? What if we have repeated linear factors that look something like this? Well, you guessed it, follow the pattern. A divided by 2x plus 3, just to the first power, plus b divided by 2x plus 3, all squared, plus c divided by 2x plus 3, all cubed, plus d divided by 2x plus 3 to the fourth power. So you can see that pattern. What if you have linear and quadratic factors? So here I'm going to factor by grouping. So you do want to factor your denominator first. We still have our numerator degree smaller than the degree of the denominator, so we're okay there. So how do we factor by grouping? We take the first two terms and see what they have in common, and then the second two terms. So the first two terms have an x squared in common, and when I factor that out of the first two terms, I have an x squared times x minus 3. Okay, and the second two terms have a 25 in common. When I factor 25 out of those second two terms, I have an x minus 3. Now, as you can see, we have a common denominator. So we went from 4 terms to 2 terms. So we go from 4 terms to 2 terms to 1 term when we factor by grouping. So what do these 2 terms have in common? They have an x minus 3 in common, and then we have an x squared plus 25 remaining. So that's what we have here, 5x squared minus 5x plus 72, all divided by x minus 3 multiplied by x squared plus 25. So here I have a linear and a quadratic factor, okay? So how do I deal with that? Well, I will let that equal a over, and we'll go ahead and write that linear factor. But now we have to have a linear numerator, bx plus c, a linear form over this quadratic factor. Okay, so you'll just have to know that form. What if we have repeated linear and quadratic factors? So here we have a repeated quadratic factor, okay? So how we will deal with that is just what you think. It's going to be the a over x. Now, since this is a square, we'll have the bx plus c divided by x squared plus 6. And now we'll have a dx plus e over x squared plus 6 squared. So that's the method. Those are the forms, and you will have to know those. So now let's take a look at this first example. Decompose this rational expression, that's what we're saying there, rational expression, where g of x is a product of linear factors. So they're saying the denominator is going to be a product of linear factors. Well, what do you notice? We first need to factor that denominator. I'll go ahead and use factor by grouping and go ahead and take care of that denominator. So x squared multiplied by an x plus 2. Here we will factor out a negative 1 and have an x plus 2. Now I'll factor out an x plus 2 from both of those terms, end up with an x squared minus 1. So as you can see, we now can have x plus 2 multiplied by x minus 1 times x plus 1. I just went ahead and factored that difference of squares. Okay, so now what do we have? Our rational expression that we want to decompose is 4x squared plus 3x plus 5 divided by x plus 2, x minus 1, x plus 1. Okay, so let's go ahead and begin. These are non-repeated linear factors. It's the simplest of the decomposition. So we say that 4x squared plus 3x plus 5 divided by x plus 2, x minus 1, x plus 1 is equal to a over x plus 2 plus b over x minus 1 plus c over x plus 1. We're making that statement. Okay, we are going to multiply both sides by x plus 2, x minus 1, multiplied by x plus 1. And when we do that, we will come up with 4x squared plus 3x plus 5 is equal to a. Now that x plus 2 cancels, and you just have an a times x minus 1 times x plus 1. This time, we will have the x minus 1 cancel, so we have b times x plus 2 multiplied by x plus 1. I'm sure you can see the pattern happening, plus c, and you guessed it, x plus 2 multiplied by x minus 1. Okay, now I'm going to let x equal 1. Then I'm going to let x equal a negative 1, and then I'm going to let x equal a negative 2. I hope I gave myself enough room there. So if x is equal to 1, I have 4 plus 3 plus 5 equals, that first term is going to be gone, 0 plus b times 3 times 2 plus c, and I definitely am out of room, so I'll just figure out where to go next when I'm finished, plus c, and we said x is equal to 1, so that would be 3 times, oops, we have 0 again. So here we had x is equal to 1 and x is equal to 1. Wiping out those terms, that's why I like this method. And we have 12 is equal to 6b and b is equal to 2. So think about it. We already have b equal to 2. Now, I think I will have enough room. X is equal to a negative 1. And we will have 4 times a negative 1 squared is just a 1, minus 3 plus 5 equals, and now we're losing this term and this term, so we have 0 plus 0 plus c times 1 times a negative 2. So here we have 6 equals negative 2c, and c is equal to a negative 3. Finally, we will let x be, think about that for a minute. What would we let x be? That's correct, a negative 2. So now, plugging a negative 2, we have 4 times 4 is 16, minus 6, plus 5. And then, having a negative 2, we will have a multiplied by a negative 3 and a negative 1. And then, don't forget, we have plus 0 plus 0. See if I can make that a tad bit smaller. And then we'll have 15 equals 3a, and a is equal to 5. Okay, so now what will we say? Remember, this is where we started, but we just solved for a, b, and c. So now we can say that 4x squared plus 3x plus 5 divided by, and we could go ahead and use the original if we wanted, divided by x cubed plus 2x squared minus x minus 2 is equal to, and here is our a over x plus 2, so that would be 5 over x plus 2. And b is a 2, so 2 over x minus 1. And since c is negative, I'll just put the negative out there. Negative 3 over x plus 1. And there you have it. We just decomposed that rational expression. Okay, let's see what happens when we have the numerator greater degree than the denominator. We will need to divide because this is degree 3, this is to degree 2. We need division. So if I'm going to divide, and we'll just do it right here. So we have to use long division. So I will have x cubed, x squared plus 8x plus 16 as the divisor, x3 plus 8x squared plus 19x. Need to move over to get my dividend written. And work right over here. And now we have an x. So now we have x cubed plus 8x squared plus 16x. We will subtract, and we end up with 3x plus 17. So we can say that this rational expression is equal to x plus 3x plus 17 divided by x squared plus 8x plus 16. If I can move that over. Okay. Okay, so now what do you notice? Now we will just decompose this rational expression, okay? And then we won't forget about this x when we're finished. Whoops. Okay, so let's go ahead and decompose 3x plus 17. And I don't know if you noticed this. This is actually x plus 4 all squared. So we have x plus 4 squared. So we have a repeated linear factor. So now what do we have to do? We have to say that this is equal to a over x plus 4 plus b over x plus 4 all squared. Okay? So now we're going to multiply both sides by x plus 4 multiplied by x plus 4 all squared. And what we will have is, multiply both sides by x plus 4 all squared. And what we'll have is 3x plus 17 is equal to a multiplied by x plus 4 plus b. So now we only need to let x equal a negative 4. So we have a negative 12 plus 17 equals b. And as you can see, b equals 5. So that was nice and fast. So we have other ways that we can do this. We might as well go ahead and let b equal 5 and just plug that in and solve for a. So if b is equal to 5, and let's just go ahead and let x equal 0, because we can let x be anything we'd like. So we'll have 17 is equal to a times 4 plus b equals 5. So subtracting 5 from both sides, and now we can see a is equal to 3. So what do we have? We can now make a statement that this given fraction here at the top with all of that is going to be equal to, so we can say x cubed plus 8x squared plus 19x. Let me see if I can move this over a little bit. So now we can say that x cubed plus 8x squared plus 19x plus 17 all over x squared plus 8x plus 16 is equal to that x, we didn't want to forget about that, plus 3 over x plus 4 plus 5 over x plus 4 squared. And that is our rational function decomposed. See if I can move that. And see if I can just write this so it's a little bit closer. X plus 3 over x plus 4 plus 5 over x plus 4 squared. That way, if this were printed, it would still be on the paper. Okay, now what's going to happen if we have irreducible quadratic factors? What's going to happen there? So g of x, the denominator, has irreducible quadratic factors. Well, so we can't reduce this, okay? So there's our irreducible quadratic factor. Well, how we're going to set this up is we're going to say this is equal to a over x plus 3 plus bx plus c all over x squared plus 2x plus 3. So we create a linear expression in that numerator. Okay? So if we use the same process, multiply both sides by those denominator factors, we'll end up with negative 8x squared minus 10x minus 6. And we can say that that's equal to a times x squared plus 2x plus 3 plus all of bx plus c multiplied by x plus 3. So here we can go ahead and let's just start with x is equal to negative 3. And let's see what happens, okay? So if x is equal to negative 3, we have negative 8 times 9 minus 10 times negative 3 minus 6. So here we have a times, and if we have negative 3, that's 9 minus 6 plus 3. And all of this term is wiped out when x is equal to negative 3. So we have a negative 72 plus 30 minus 6. And here we have (6a). And so if we have a negative 72 plus 30, and then we subtract 6, we will have a negative 48 equals 6a. And of course, a is equal to negative 8. Now, what we don't have here is we don't have another value that would cancel a term out. But since a is equal to negative 8, see if I can move this over a little bit. Since a is equal to negative 8, we can go ahead and let x be anything we want. Why not 0? So if a is equal to negative 8, we can let x be 0. And that will help us solve for B or C possibly. Okay? So we have negative 8 times, and that's going to be 0, so we have a 0 term. That's negative 6 equals A times, A is negative 8. Negative 8 times 3 plus, since x is 0, we have C times 3. So we have a negative 6 equals a negative 24 plus 3C. And we have 24 minus 6 is 18 equals 3C. And so C is equal to 6. So now what we could do is we could just let x equal 1 if we wanted. Or you could plug those in. Let's just let x equal to 1. So we have x equal to 1. A is equal to negative 8. And B is equal to, C is equal to 6. Here we go. Again, we're going into this equation right here with those values. Okay, so if x is 1, we have a negative 8 minus 10 minus 6 equals, A is negative 8, 1 plus 2 plus 3 plus, we don't know B, but B times 1 is just B plus C, which is 6. And then if x is 1, we have times 4. Okay, so this is a negative 24. And then we have negative 48. And then we have B plus 6 times 4, which is a 4B plus 24. So if you notice, we end up with a negative 24 on this side and a negative 24 on the other. So we get 0 equals 4B. So B is actually equal to 0. So with all of that, we have our original rational expression. It is equal to, maybe I shouldn't put that bracket there. This is actually equal to negative 8 over x plus 3. And then if B is 0, it's just equal to 6 over x squared plus 2x plus 3. And that is what this rational expression is equal to. Okay, let's take a look at number 9. What do you notice in number 9? And this is the last problem we're working. You guessed it. We have repeated quadratic factors. And that was pretty straightforward. Remember, we will write them as individual, not squared, and then we will write it over the squared term. So let's just give that a try. We're saying that this is equal to A over just that factor, not squared, plus we now have, that's not right. We have ax plus b over x squared plus 6 plus b cx plus d over x squared plus 6 all squared. So that's how we set up the decomposition when we have repeated quadratic factors. Okay, so there are other ways to solve. So I'm going to show you another way. And this is the way And you could still solve it the other way. Previous method still works. But let's solve another way, okay? Same method that we begin with. We're going to go ahead and we're going to say that 5x squared plus 2x plus 31 is equal to ax plus b times x squared plus 6, one of those factors, plus cx plus d. So what did we do? We multiplied both sides by x squared plus 6 all squared. X squared plus 6 all squared. Okay. And there we have it. Okay, so what we want to do here, this is another method, is we're going to multiply those factors here together. So let's multiply these together. So we have ax cubed, that's the first, plus 6ax, that's outer, bx squared, that's inner, plus 6b, that's the last of FOIL. And we still have cx plus d. So here, whoops. I'm just showing that that's what we multiplied. Okay, so what we're going to do is we're going to gather like terms. And this is the method that's in your book. Okay, so we only have one cube term. And we only have one squared term. Our x terms are here. And our constants are here. So with that, let's go ahead and put in parentheses 6a plus c, and that's our x term. And then our constants are 6b plus d. So let's talk about this. 31 must be equal to 6b plus d. 5 must be equal to, whoops, b. And let's change colors. 2 must be equal to 6a plus c. So what do we know? You could think of this as 0x cubed. You could think of it like that. So what do we know? We know that a must be equal to 0. So a is equal to 0. We know that b is equal to 5. We know that 6a plus c must be equal to 2. And we know that 6b plus d must be equal to 31. Well, since we have a equal to 0, we can now see that c is equal to 2. And we have 6 times 5 plus d equals 31, and you can see that d is equal to 1. So coming up with these terms and comparing the powers is another way. Now, it takes probably the same amount of time with the previous problems to work them that way. You still have to solve a system, but this one works out really nice. So let's go ahead and write down our final answer that we come up with. Okay, so looking right up here, we're going to say that 5x squared plus 2x plus 31, all divided by, whoops, I don't know how that color changed, all divided by x squared plus 6, all squared, is equal to ax, which is 0x, plus b over x squared plus 6, plus 2x plus 1, all divided by x squared plus 6, all squared. And there is our decomposition. And that concludes this video.